Many electrical and mechanical systems can have embedded systems attached to add specific additional functionality. This assumes those systems have a motherboard inside to which an extra embedded system, aka another circuit, can be embedded or attached to that original motherboard. So, to further illustrate this point, let's imagine we have a computer system, aka an electrical system, and also a mechanical system, e.g., a HVAC, a heating, ventilation, and air conditioning unit. And to visualize the important point, both of these systems have a motherboard inside. And this is where an embedded system is any form of computing component added to that existing system that provides enhanced specific functionality. This could be providing automation, remote control, and/or monitoring. Important CISSP exam tip. Remember that an embedded system is typically designed around a limited set of functions in relation to a larger product to which it is attached. It may consist of the same components found in a typical computer system, or may be a bit more bespoke. Ultimately, an embedded system or component can be thought of as a microcontroller. E.g., a microcontroller controls a larger controller such as a system, or may simply be used in conjunction with a larger system to form a specific functionality or enhanced service. So now we have an understanding of the historical and practical concept of an embedded system. Let's therefore dive a little bit deeper and get technical. So the embedded system component generally comes in two forms. The first is System on a Chip, SoC, not to be confused with Security Operations Center. So to visualize how a system on a chip would actually work, let's get a little bit deeper into the actual chip. So if we magnified that chip, it would look something like this. Important CISSP technical note. There is a distinction between a SoC and a microcontroller, and thus it is important to distinguish between the technical reality and what is marketing hype. You see, at the core, a microcontroller is the embedded chip, and this can either be complex or less complex depending on how many elements are soldered or integrated into that chip, which in turn can either give the chip a very complex or less complex functionality or pool of functions, which makes it either more powerful or less powerful. Of course, the context of what the embedded system is being embedded into must be taken into account. Now, to further visualize and get even more technical, let's look at the individual components that we might want to solder into the chip or system on a chip, which is essentially, remember, a microcontroller. So, for a system on a chip, we might take a lot of these components and duplicate them. For example, we might want a CPU feature and a print feature, USB, internet, RAM, storage, etc., etc., because we are trying to mimic a real full system or a computer on what would be a small hand-sized little chip that gets integrated onto a larger motherboard. Now, if we want to build a less powerful embedded chip, aka a microcontroller, rather than a full system on a chip, we might just solder a small amount of components that is needed to achieve a specific function or task. And again, to reiterate the importance for the CISSP exam, here are those same key notes about the difference between a microcontroller and a system on a chip, both from the technical and marketing perspectives. Moving on to some real-world examples of microcontrollers, starting with the popular Raspberry Pi. Usually a 64-bit microcontroller or single board computer. These types of microcontrollers provide a small form factor computer that can be used to add computer control and monitoring almost anything. Whilst a Raspberry Pi may be a small little device, it can contain a CPU, RAM, video, and peripheral support such as USB and input-output related components. Advanced models can even contain networking related ports. To bring this back to a visualization, this is how small a microcontroller would look, and this is how it would connect to a larger device, aka embedded into a larger system. So just to recap that visualization, here's some text that basically cover what I just explained. The next common microcontroller is known as the Arduino. The Arduino is an open source hardware and software organization that creates single board 8-bit microcontrollers for building digital devices. However, unlike the Raspberry Pi, the Arduino has limited RAM and a single USB port and input-output pins for controlling additional electronics, such as those related to a small motor or maybe LED lights. Key technical note: an Arduino, unlike a Raspberry Pi, does not include an OS. I repeat, it does not include an OS, aka operating system. Instead, an Arduino can execute C++ programs specifically written in its limited instruction set. In summary, whilst a Raspberry Pi is a miniature computer mimic, an Arduino is a much simpler device, thus has less components than a Raspberry Pi on its circuit chip. So don't intend for an Arduino to mimic a full computer system. And lastly, a field programmable gate array FPGA is another type of microcontroller. However, these are often embedded devices into the circuit chip of the main controller, and these are often very powerful chips embedded into a wide range of products, such as those in the Industrial Control Systems (ICS), and is ultimately a programmable hardware chip. And to finish on embedded systems, let's consider some of the security risks. Well, the first major risk is that embedded systems are generally static systems, meaning they are deployed into larger systems, and the admins do not always have ways to ensure the security and patches are available and implemented as they should be. This creates various security risks, especially given embedded devices can control some very specific systems or very important systems. So that concludes embedded systems. But hang on, there's a new thing in town called cyber physical systems. So just for reference, in case it pops up in your CISSP exam, what was referred to as embedded systems in the past now have extended scope. This is due to the artificial intelligence, AI, and robotics, and all the various Internet of Things devices that have blurred the lines of what devices control physical world elements. This is a very fast evolving space, so it is worth keeping in the back of your mind as you study for your CISSP exam. Thank you for watching today's video. I hope you enjoyed the content as much as I enjoyed creating it. If you would like to see more content like this, it would be super fantastic if you could leave a like and subscribe to help support this channel's growth.